Hey, hello everybody, this is Stereo Police, and I know it's been a while, but I've had this H.H. Scott Stereomaster 222B on my workbench for a year now because I just took a break from audio altogether, got busy on quite a few things, and it's been sitting here for a year because, well, I was tooling around with it here on the bench, and all of a sudden one day one channel went out. And I did a signal trace on it and found a bad capacitor. And so I ordered some new capacitors, one for each channel to replace both of them to keep it symmetrical. And that bad capacitor was a pretty critical capacitor. Not that any of them are not critical, but that bad capacitor was in the line of the phase splitter. So here are your output tubes right here, and prior to the output tubes you've got your driver tube, which is your 6BL8. And the 6BL8 is a vacuum tube that is two tubes in one. It is a triode pentode, so one side is a triode, the other side is a pentode. And so here's the triode side, and it acts as an amplifier. So the signal comes in from the preamplifier side, which has the 12 AX7s in it, comes in from the preamplifier into the pentode where the signal gets voltage amplified. All right, and then the signal flows down here through this 100K pot and then into this capacitor right here, and that is the bad cap. And that capacitor is a 0.022 microfarad right there, and it connects between the 100K pot and pin 9 of the triode. And let's go right over here. I've already taken the bad cap out, but let's see if we can get a look at where it goes. Get the light going here. Okay, I've got my pin on pin 9. So it would go right there, and it would connect over to the 100K pot right there. So that's where the new 0.022 is going to go. And then on the other good side, on the other channel that's good, here's the equivalent cap right there. And they had whoever rebuilt this amplifier and recapped it, they had different caps on both channels. Let's say they had an orange drop type cap down here, which was the bad cap, and they had this yellow one up here. This is an existing cap right here. So I'm going to replace them both with these orange drops right here. So they're 0.022 400 volt caps. And that ought to be perfectly sufficient. These are good high quality caps right here. And first thing I'm going to do is test the caps with a capacitor meter to make sure they are what they say they are. And then I'm going to clip their leads down as short as I can possibly get them. I'm going to go ahead and solder that in there, that channel right there. And then do the same for this channel up here to get matched channels. And then go ahead and hook it up and pray that both sides work. They did for a while until one channel went out, and it literally was a bad connection. I mean, for example, I'll just pick one of these caps right here. It literally was, for example, if you were looking at this cap and looking at the lead, it was just severed. and the two parts were just touching. And every now and then, if I would bump the chassis, you'd see a spike in the signal. And that was the lead disconnecting and reconnecting. So it was like a switch. And then one day the channel just went out. And that was just the lead not making a connection. Probably depend on the weather and things like that, you know. I mean, the temperature, and it was just a bad connection. So I'm glad I found it. And let's go ahead and get started here by testing, making sure these caps are good. And go ahead and finish this repair, because I do want to take this Scott up to my cottage, which I have a new audio cottage now. If you looked at my previous videos from a year or so ago, I had what I call the audio cottage, and that's now rented to somebody. That's a long story I won't get into, but I have another place I go to listen to gear. So, and here's my workshop. It's the same workshop that everyone's familiar with who had watched my previous vids. These are the containers where this is all stuff here related to the HH Scott that I'm currently working on. So everything on the bench here is related to the Scott. And I purchased some new tubes for it. It came with a mix of tubes in it, and I had originally had a problem with this tube here, the rectifier. It was arcing, and so I replaced the rectifier, and that was a perfect fix. And so I went ahead and the output tubes were a mixed hodgepodge, and let me see if those are the new output tubes. They're not. That's the hodgepodge right there. But I purchased a match set of the EL84 output tubes, and I'm going to sub in there and try those out, see if I like them. And the 12AX7 tubes down here, the preamplifier tubes, those are all new old stock General Electric, and they sound good, and I'm going to leave them there because they're all matched. I mean, they're all the same company. And then these guys here are the same company, and they're matched. I can't remember what they are. It's been a year since I looked at that. It's just the output tubes that are not matched, so that's why I purchased the match set. So let's get started with this repair and see how this goes. Okay, so I like measuring my components before I install them, and you can see the first new capacitor measures perfectly. 22.2 nanofarads. It's 0.022 microfarads. That's pretty doggone it close. We're set on the 200 nanofarad range, so that's pretty good. Let me set the camera down for a second and hook up the second one, and hopefully the second one is pretty well matched, because I want one for each channel that are nicely matched. These are not polarized, so that's not an issue. Oh, 22.7, so there's the second one, and we're 22.7, so they're very, very nicely matched caps. Good stuff. So now I know I have two caps that are matched, and we'll go ahead and start the install. And part of starting the install, I was soldering something earlier, and I've got a pretty blunt, there's a glob of solder on there. I shouldn't have left that on there. I've got a pretty blunt tip on the soldering iron, so I've got to select the tip and select a proper heat, a proper temperature range on. And I'm not quite sure. I've never been the greatest at soldering, but I'm guessing something around, for these leads, around 500 to 600 degrees, and I'm going to experiment. You want the lowest temperature possible, but still get the job done quickly. You don't want the heat on there very long. Not an expert solderer. Never was formally trained in it, but anyway, let's get the bench cleared and I think I'll get that guy desoldered and prepped first. Okay, here's where I am. I'll just give a little update every now and then for those who are interested in repairs. So I've got a, where are we at here? Get my pointer. There's the new orange drop right there, and I've got a mechanical hook in one lead. I haven't soldered it yet, so I've got a mechanical hook. So we have a mechanical connection. You never want to rely on solder to make the connection. You want a mechanical connection, and solder just completes the joint. And then I've cut enough lead on the bottom to reach the potentiometer, the 100K pot, but I'm not going to make that connection until I solder that one right there. And I've temporarily strapped this line up to get it out of the way. I'm going to cut that zip tie when I'm all finished. And I'm going to go ahead, got the soldering iron ready. I've got the soldering iron ready to go, solder ready to go, and I'm going to give it a shot, see if I've selected a good temperature, and see how that goes. Okay, I've got the upper one soldered, and I've got a good mechanical connection on the lower, and about to solder that one. All right, there it is. And I had to clip a little excess on the bottom, and this is going to have to be folded a little bit, because there we go, there it is. It's going to be folded, and the reason it's folded is because when the bottom plate goes on, it would push it down anyway. There's very little clearance between the bottom plate and the circuitry here. And there she is. And now I have to do the same for down here, so I'm going to flip the whole rig. We can go ahead and get that now. I'm going to flip the whole rig upside down, and to get that a little higher. Always like to have a little fan going when I'm soldering to get that smoke out of my face. Alright, let's flip her over and do the other, and then fire it up and see if this thing doesn't blow up in my face. Alright, got the first mechanical coupling right there, and I went ahead and put a little bit of flux on the joint because that existing joint in there looked filthy. And here's the solder I'm using. I have different types of solder. I have lead free and various types, but I am using actually solder with lead today. So it's 40% lead, 2% rosin core, so it has flux in it, but that's not enough flux to handle that disgusting joint there. So I just added a little bit. I just have this little tool I use, and I just added a little bit of flux, and that'll burn off right away and clean that really filthy joint. I'll go ahead and get that soldered up and then finish the connection to the 100K pot. Alright, and here it is. So got that connection down there and got it connected to the 100K pot. There's our, so now we have matching 0.022 microfarads, which is a critical in signal path capacitor. Absolutely critical. So now they're matching on both channels, and they should work. Don't have any cold solder joints. Solder joints are good. And I am ready to clean up my bench and put a test signal through here and look at it on the scope. That's going to take a few minutes to get that rig set up. Okay, here's where we stand. I've got the amp plugged in. Still got what looks like the original power cord. That could probably stand to be replaced, but I'm using an audio signal generator. I believe it's set up for 1 kilohertz, which I like to use generally for testing. That audio signal generator is plugged into the tuner input. It's currently producing this sine wave right here, which is measuring in at 1 kilohertz and roughly 800 millivolts. That's fine for an input. Generally 1 volt RMS is fine to feed. I find is fine to feed as an input to a device like this, to a line level input. Between 1 volt to 2 volt RMS. I can tweak that around. I've got, for speaker load, I'm set up to back here to apply or to attach the speakers left and right channel to the 8. Do I have yeah, I'm on the 8 ohm taps, and I'm applying them to these 20 watt 8 ohm non-inductive power resistors. Non-inductive power resistors. That should be the same. 20 watt non-inductive. Yep. And I'm going to be scoping this one, but I'm going to be able to move the scope back and forth while monitoring the input signal, which is a blue trace, and a yellow trace will be looking at the output. But first, now I've had this H.H. Scott working before, so I'm pretty certain nothing's going to blow up. I don't need to take the usual safety precautions that I normally take if it's an unknown device. However, I'm still leery. I'm going to turn it on and get ready to turn it off while it heats up. It could take a tube amp up to a minute or two to actually things to get heated up and the juice is flowing, the current's flowing, the capacitor's charged, etc. And sometimes weird things happen. It might take once the circuitry capacitors start charging, things like that. That's, it might take 30 seconds up to 60 seconds for weird things to happen. For example, for tubes to start arcing. So I'm always at the ready to turn it off. So I'm going to go ahead and turn it on. I'm not going to touch the chassis. And nothing's happening. The light's not glowing. Why isn't my light? Oh, the pilot light. Now it's glowing. Okay, that took a minute. The pilot light even takes time to start to get warmed up. Well, there's some ancient gear. So pilot light is now on. And I can see that the rectifier tube is glowing, and I can see the output tubes are glowing. And I'm at the ready to turn it off. I've got this weird thing from experience where I always like to do a quick tap test to see if I get shocked. I'm on an insulated mat, but still. Smell for strange smells, listen for strange sounds. Volume is completely down. I don't see anything happening. Not going to turn the volume up yet. Okay, I'm going to start turning the this is all set to everything's neutral, bass, treble, all that. Not that it matters, but and the balance is in the middle. And I'm going to start turning the volume up with my left hand as I look at the scope. And I'm just going to do an auto set on the scope to find the signal. Okay, so The yellow signal is going to be the output from this channel here. And right and left is really a relative thing on this tube amp. It doesn't really say right or left. But I can tell you, if I turn the stereo balance all the way to the left, the yellow trace goes away. So that means that that's the right channel. Right there. I'm scoped to the right channel. And the right channel is the bottom bank right there. The bottom taps. That'd be interesting to note. Okay. All right. So there's our right channel, and I'm going to turn it up. Get my glasses on here till I see clipping. And then turn it back down. See, there's some crossover distortion and clipping. Turn it back down and do an auto set. And we're looking at about 8.96 volts RMS right there. All right. So that channel worked fine, the right channel, 8.9 volts. It's about 10 watts, okay? I just did the calculator, 9 times 9 divided by 8, V squared over R, okay? So that's about 10 watts. What the heck, I forget what this amp is spec'd out at. 10 watts before visible clipping. I'm not going to measure. I don't remember what this thing is spec'd out at, to be honest with you. Anyway, that's about 10 watts, which is about probably what I'd expect. I probably did a video about this amp a year or two ago, and whatever I said the specs were, but that's about 10 watts. Now let's do the other channel. The left channel. Auto set. All right. Now that's clipping early, and that's a weird. That's like a flat top. That is strange. Let me get that down to right before visible clipping, even though it still looks ugly. And we're only at 2.65 volts RMS before visible clipping. And that's only like a one clean watt before visible clipping. So there's something wrong with that channel. That is not good. Something is wrong. Now, my first inclination, I don't remember having this problem before, but I can tell you these are the original output tubes, and one of them is mismatched and old. So my first inclination is to replace all the output tubes with the new output tubes. And there are some settings some adjustments I can do here as well. Bias is one of them, but the bias adjustment shouldn't affect anything that radically. But what I'm going to do is go ahead and turn this amp off and replace the output tubes as starting, because this is a push-pull amplifier, and we're getting clipping, asymmetrical clipping on one side, which could indicate one bad tube. Could. And that's my first inclination, so let's go with that. No difference. The left and right channels are still doing the same thing. So I don't have time to, this is going to require a signal trace, but I'm going to do one quick thing to see if this problem exists without doing the signal trace, if this problem originates in the preamplifier section. And what I'm going to do is turn off the amp, and I'm going to take, I know that we have some symmetry up front here, so I'm going to switch the 12AX7 tubes, these two for these two, and vice versa. I'm going to switch them out, mirror image, and see if the problem exists. Right now it exists on this channel and not that one, and see if the problem flips channels, just to see if it originates in the preamp section. And that way I know when I pick up next time, when I start doing a signal trace, if I can just start tracing backwards, which one I tend to do anyway, but just start tracing backwards. But even before I trace, I'm going to adjust the bias to get that set, but there's no way the bias adjustment would cause something that radical right there. I can tell you that. I've already put a screwdriver, you know, into the bias pots right there and moved it around left and right, and you know, nothing happens. I mean, nothing's gonna happen. The bias pots don't allow you enough leeway to cause any major distortion like that. I'm going to turn this off and switch preamp tubes just to see if we end up switching channels with respect to the distortion. But I suspect this problem exists somewhere in the output. Here's my schematic. Got a really bad schematic right here that's all marked up, but it's going to exist somewhere around here. And we're just going to keep tracing back until we find it. I don't recall that having... I recall a channel mismatch back a year ago when I was working on this amp, but I don't recall it being that bad of a channel mismatch. I wonder if I still have my notes. I don't recall a channel mismatch that radical. That's 1 watt on one channel, 1 clean watt, and 10. Let me see something here. And 10 clean watts on the other. That's some crazy stuff right there. There's no way. I mean, there's an issue. Let's see if I have my notes from a year ago. Well, when you pick up on something a year later, I'll tell you. I'm surprised I remember this much about it. Let's see. I know I took some notes down about, because I was measuring distortion with my total harmonic distortion meter, and nope, I don't know where those notes went. Back of this. Alright, well, let's go get those 12AX7s flip-flop and see if it does the same thing. If it does, I'm going to call it a day, and I'll do some signal tracing later. Alright, no difference. So there's an issue somewhere in there. It's going to require a little more troubleshooting, a little more time than I have tonight. So that's disappointing. I was hoping to actually listen to this thing. But so be it. More troubleshooting. That's okay. It's all part of the fun, I guess. Anyway, good to be back. I think it'll be an adventure to see what the heck is wrong with this thing. I have some ideas, but it's only speculation. But I need to get the various adjustments done first, and the bias done, and there's a couple of other adjustments to be done on this thing. And I'm going to get that done first, and then I'm going to run through some I'm just going to do a signal trace, find out approximately where the issue begins, where the signal becomes unclean, and then try to trace it down to the component level. But I've got brand new tubes in there, and I don't know what. Some component is bad to cause this. Maybe it's not going to be an output transformer. Anyway, good to be back, and I will talk to you guys real soon. I'm just going to call this H.H. Scott Part 1, I suppose. Didn't intend it to be Part 1, but ciao. Hey, I'm back. So I thought I was going to wrap that video up, but I made a classic mistake. Before I left, I was just fishing around thinking, you know, it's such a weird problem that I didn't do what I normally do after I solder. And that's go back and look at all my connections and make sure that because I was bending leads around, in other words, I'd soldered those capacitors in and I'd sort of bent them down, I should go back around the pins of the tube and make sure that I didn't cause any components to touch each other, any leads to touch each other, and that's doggone sure what happened. I have it on right now, so I'm going to show you where, but basically let me grab a pen. Up here, in the connection up here between pins 8 and 9, where's my pen? Gotta get it in the viewfinder here. Okay. It's a weird camera. There we are. Between pins 8 and 9, when I bent this new capacitor that I put in over, I caused pins 8 and 9 right here. I caused these components to touch each other. They were literally touching, and they shouldn't have been. And that's on that triode, which is the phase splitter. So to show you on the schematic, there's pin 9, and I believe it's pin 1. Okay, so pin 9 is the grid, and it looks like pin 8 is the plate. I'm sorry, the cathode. So the cathode and the grid were touching. Or at least, yeah, that's what was happening. Now, how that would, it seems like that caused a really weird waveform. I'd have to analyze why that would cause that kind of odd clipping, but I'm not going to because I really don't care at this point. But here's the result, and the result has been good so far. So same setup, and let's look at each channel. I've got balance in the middle. I've got 1 kilohertz, roughly 1 millivolt RMS input, and we're looking at one of the two channels now. And what I want to do is I want to take it up and I want to find the point of visible clipping and then back down. There's visible clipping, and I want to back down to where it looks fairly decent. Make that a little bigger. To where it's fairly decent looking, which typically would be under about 1% THD. And then I'm going to look at the RMS voltage, which is 8.8 volts. All right. So that's on one channel. We have 8 volts. Of course, that's going to be 8 watts. And let's do the same. So 8 watts, 8 clean watts. Now let's do the same for the other channel. 8 clean watts, and now we're going to do the other channel. We're going to look for visible clipping and crossover distortion back down to where it looks good. And there we have 7.72, roughly 8, so that's good enough. Both channels are behaving similarly, and that's all I need to know. And that's nice. So what I want to do now is adjust the bias, because I did put some new output tubes in, and when you do that, it's a good idea to adjust the bias, and there's a procedure to do that. And I'm going to hit stop here, and I need to pull that procedure because I forget what it was. I did it once last year, and I have the instructions for that somewhere right here. Alright, I'm set up to do bias, and per the instructions. Bias adjustment, it's pretty simple. Remove the bottom plate, which I already have. A DC voltmeter across the 1.2K resistor R201, and adjust the bias control pot until the meter reads 38.5 volts. And the bias, it's my own words now, the bias controls the bias for all 4 output tubes, so it's one adjustment for all 4 tubes. The 1.2K is right here, and it's a 7 watt. It's a big boy, so it should be pretty easy to find. 1.2K is brown, orange, I'm sorry, brown, orange, brown, black, orange. What the heck would that be? Man, it's been so long. One is, gosh darn it, brown, red, and orange, right? I think brown, red, and orange. Okay. Now, brown, red, and orange, and it is back there. This is a hot amp, so I'm not going to be pointing too closely, but I have my Radio Shack voltmeter that I've been using for decades. My good meter is at another house right now, but I've been using this for since the early 80s. When I was a teenager, I bought this, I think, and it still works. And I compare the readings sometimes with my good meter, and I still use this in certain applications, and the doggone thing never dies. So I have it set to DC volts, and I have it, we are connected across that big fat 7 watt right there, and the potentiometer to adjust. Well, currently we're reading 37.5 volts, which is pretty darn close. Pretty darn close to being, what was the reading? 38.5. And the pot is that one right there. I'm not sure this is going to fit. I need a smaller screwdriver. Let's see. Yeah, what'll do? Get that one in there, and we need 38.5. Oops, wrong direction. Well, I'm turning it. See, that's the wrong direction. I've turned it all the way to the left, and that's as far as it goes. Turn it to the right, turn it clockwise, and it goes way down. And I turn it counterclockwise as far as it goes, and that's as high as I can get. So 36 to 37, and if I start turning it clockwise, so you can see we go way down. So counterclockwise as far as it goes. That's as good as we can get. So the bias, we are as good as we can get bias wise. And let me go ahead and double check our signals here. Make sure I didn't screw anything up in the process. Good. Peak signal there, and let's look at the other channel. Same thing. And I'm not going to do a THD with the THD meter. That's a good enough clean signal, and I know good enough from experience that I mean, I can take this signal right here. Oops, the daisies. I could do an FFT on it, and where are we at? Hold on a second. Choir. All right. There's our FFT, fast Fourier. So our fundamental is that big spike on the left, and there's our harmonics right down there. And the harmonics are pretty low. There's a little second, and everything looks fine. There's nothing, no major issues going on right there. I'll do the same thing. Let's do the same thing for the other channel, with all things being equal. Okay, do an FFT there. Let me spread it out a little bit. That's fine. There's no issues. So now we got the bias set. This is going to be a good running amp. I am going to hook it up, put the plate on, go ahead and turn it off, put the bottom plate on, and go take it to a good pair of speakers and give her a listen. I'm pretty doggone satisfied with it. I'll show it to you when it's all put back together again. All right, there we go. This bottom plate kind of slides in from the top. It's got a little lip that hooks in here, slides down. It had 3 screws down here. I'm not sure these were screws that weren't in it when I got it. And look at that, almost fell. And I put the rubber feet on. It probably had some rubber feet at some point, and doesn't right now, so I put the rubber feet on myself, and I just stuck them on with 2-sided tape just to elevate the thing. And you can see it needs to be lifted up a little bit off the ground. Otherwise it'll scratch the furniture that it's on. You don't want that faceplate touching whatever it sits on. And then I put the RFI shields, or the EMI shields, whatever you want to call them, on the 12AX7 preamp tubes, small signal tubes. And we're complete. Looking good. And I found some of my old notes from about a year ago where I was getting inconsistent results between the 2 channels. One channel was producing about 7.2 watts, the other was 5 watts. And today, when I was taking those measurements, I was getting about 8 watts a channel, both consistent between channels, so I'm pretty happy with that. And pretty thrilled overall. I can't wait to give it a listen, especially now that I know that the bias is set correctly. Looking forward to it. The next video I make will be with this, playing some music through the Forte 3s. All right, I'm going to call it a day on this video. I'm not even going to make a part 2 or anything like that. This is just the The repair I had to make on a restored H.H. Scott 222B that I purchased. I purchased it allegedly restored, which it was partially restored, but of course, out of the box, it had issues, and I had to fix it myself. Fix those issues. A good thing I had the equipment to test it, because I purchased it restored, and when I put it on the bench and tested the THD, I found the inconsistencies between channels, and then I found that capacitor issue, and but it's a good thing that I was able to test it to know that it wasn't running to spec, and now that it is. So looking forward to now listening to it, knowing that it's running to spec, and I can hear it the way it's supposed to be heard. Thanks for watching, guys, and good to make another video after quite some time, and hope you enjoyed it. Take care. Stereo Police out. Ciao.